Okay. Did you manage to forget everything over the weekend? Good, done. Now we can remind ourselves of what we were working on. So just a quick review, because I've also got this little exercise that we'll do as review. But we started talking about lines, and we're just going nice and slow, potentially too slow. That's okay, just warming up. So to graph a line, we only need 2 points, right? And so we only need 2 points. And then if you have those points mapped out, then you can connect them with a straight edge and draw the line and extend the line, and then you've graphed a line, right? What else do we only need 2 points for? We only need 2 points in order to find the slope of the line, right? And so to find the slope of a line, we only need 2 points. 2 points on the line. I'll need more room then. Bump that down. Generically, x1, y1, and x2, y2, right? And we said, okay, the slope is usually denoted by a lowercase m. And I always mean to look up what the logic is there, why it's m, but I don't know. Jury's out still, I guess. But m, and let me just remind myself which order we did. The thing is, the order doesn't matter, but I want to be consistent with what our little blurb said. So here, the slope, we used y2 minus y1 over x2 minus x1, so I'll be consistent. The order is not going to matter, right, as long as you're consistent. Okay? But we're going to use y2 minus y1 over x2 minus x1. Right? You've got some xy coordinate for point 1 and some xy coordinate for point 2. Okay. And then we kind of did some work with the slope, right? And some special cases, right? A special case was a horizontal line, right? If you imagine the horizon, a horizontal line goes like this, or maybe you're really good at just remembering what horizontal means, but I'm not. The special case would be a horizontal line. Which would have a slope of, we imagine a line like this, a slope of 0, right? The rise is whatever the y is minus whatever the y is, it stays the same for both points, right? And so then your rise is 0. 0 divided by anything is going to be 0. And so then the slope is 0 for a horizontal line. What about a vertical line, right? So a vertical line, a vertical line the slope is going to be undefined, right? That was one of the things that we said. I think I even put some big exclamation marks, right? And that's going to come back to haunt us. So I'll write it again, right? A vertical line looks like this, right? Maybe I have a line like this. And the slope, if we bring it back to rise over run, right? Because I don't want to talk about generic y2 minus y1s, that's the rise and then the run. So if I have a rise over run, well, the rise is going to be the distance from between each of those points. But the run is 0, right? And so then I would be dividing by 0. Right, and so here, the run is 0, right? But we can't divide by 0. That's illegal math. Okay. But we can't divide by 0. Right? So 0 over something just becomes 0. But if we're trying to divide by 0, we can't, right? And you can try it on your calculator. Your calculator will try to stop you and say, oh no, mine I think says math error, right? If you're trying to do some illegal math, then it'll warn you. Yeah. We also did mention kind of the most common form of writing out a line, the equation of a line, y equals mx plus b or some version of that. But I want to do this exercise the hard way. What do I mean by the hard way? So that we can kind of solidify how to read these equations. Any questions about the review before we do that, though? Okay. All right. So we're asked to, whoops, where's my pointer? Look at the slopes and the y-intercepts of the following lines. So what I'm going to do is I'm going to just label these 1, 2, and 3, and 1. If you're familiar with y equals mx plus b, the slope is whatever's attached to the x, right? And so 3 in this case. So we already know the answer, but I do want to show you kind of the long way to get there so that we can kind of start merging all these skills. Okay, so what can we do? If I had to graph this line, right, I could plug in some value for x and solve whatever the y would be on this line, right? And so then if I did that twice, I would have 2 points. Remembering that what we said was, okay, to graph a line, we only need 2 points, but also to find the slope of a line, we only need 2 points. So either way, we only need 2 points and then we're ready to move on. So let's see here. So for line number 1, y equals 3x plus 2, right? We have this idea that, okay, if I have it in this format, y equals mx plus b, then the slope would be 3 in this case. But let's confirm it. So we can find 2 points. If I let x be anything, pick convenient values of x, I'm going to avoid 0. That's usually my go-to move. Okay, but I want to save it for the y-intercept, because what's the y-intercept? If you think about your graph, right? Your y-intercept, this is your y-axis and this is your x-axis. That's from last day, right? Your y-intercept is wherever it crosses the y-axis. What happens at the y-axis? That's wherever x is 0. So then you force x to be 0 and it'll solve for the y, and that's where it'll cross the y-axis. Okay? And so that's why I'm holding off. Or maybe we should just do x equals 0. Might be nice. I changed my mind. Okay, let's do 0. Save ourselves half the work. And it's easier to calculate. Right? If x is 0, and maybe I'll just, are you guys okay if I shrink this up and put it kind of up here in the corner instead? Nice. That was just a reminder. Yeah. Then y in this case is 3x plus 2. Yeah. So you can plug in x equals 0 and find that y is going to be, I'll do the long version here, 3 times 0, which you have to do first, right? So 3 times 0 is 0 plus 2, right? Multiplication before addition. Brush up on your BEDMAS. Or do you call it PEMDAS? There's like I think in the States they call it PEMDAS or something like that. Brackets. We call them brackets. They call it parentheses. Fancy, right? Brackets, exponents, division, multiplication are kind of confusingly on the same level, and you do them in the order that they appear. So usually if you're, scrolling your social media and you get one of those, so many people can't, if you get this math problem, then you're a genius. They just don't know that you do multiplication and division, and then addition and subtraction are on the same level, and you just do them in the order that they appear from left to right. Kind of cool. There are still rules. No one can solve this math problem. Wow. Someone can. So 3 times 0 is 0 plus 2. Pick a convenient value of x. How about 1? Once we start seeing fractions and things like that, then it'll be more important to pick convenient values of x to substitute in. But for these whole numbers, it doesn't really matter. 3 times 1 is 3 plus 2. I'm going to go with 5, which means that here, in terms of my xy coordinates, I have 0, 2, and I have 1, 5. We did say that this is our y-intercept. So the y-intercept here is when x equals 0, and it's the y-intercept is at 2, or y equals 2, if you prefer, but you can just do 2. And like I said, we're doing these the long way, but we are expecting the slope to be 3, right? We have that knowledge. And so how are we going to get there? We can confirm it. We can confirm it by saying the slope, m, is y2 minus y1 over x2 minus x1. Now, as long as I let one of these 2 points be 0.1 and the other one be 0.2, it doesn't matter which one I let be which point. But for simplicity, let's let the first one be 0.1 and the second one be 0.2. So then I get y2 is 5 and y1 is 2. And x2 is 1 and x1 is 0. Five minus 2 is 3 last time I checked, divided by 1. I get a slope of 3. I'll clean that up there. Kind of cut through that 2 there. Which, we look at the equation, right? We've got the slope times x plus the y-intercept, right? Which is why it's called the slope-intercept form of a line. Right? Can I leave these for you to try on your own? We can move on. You can try them on your own. How about this? I'll post, I'll sneak in a page before I post the notes, just like I did last day with it worked out, so you can check your work. Right? But like I said, we're just doing a longer way of finding the slope than we need to. So if we are able to rewrite a line as y equals mx plus b, then m is the slope and b is the y-intercept. Which brings us to the next section. The equation of a line. Slowly getting through lines. Graphing a line, slope of a line, the equation of a line. That seems like an important one. Next stop, the intersection of two lines. I know, crazy. All these things we can do with lines. So this is called the y equals mx plus b is called the slope intercept form of a line, right? Because it outlines the slope and it outlines the intercept. I don't expect you to remember what the different forms of a line are called, right? And if I do need you to, there are three different forms of a line that we can kind of set up an equation of a line that we're going to talk about today. And so I don't need you to memorize that. If I need you to know it, then I'll tell you, right? The slope intercept form of a line is y equals mx plus b, right? Just like that. You do need to know that here, let's do this. You do need to know that if I give you the equation in this format, then whatever is attached to the x is the slope, and whatever is on its own is the intercept. And notice how I'm not writing the y-intercept, it's implied. Okay? We don't incorporate the x-intercept, which is where y equals 0, right? Unless it helps us draw a line or something like that. And so here I'll say the y-intercept, but usually we just call it the intercept. Again, we'll start nice and small. What if you have to find an equation of a line whose slope is 5 and y-intercept is 3? You can start with an empty line, y equals mx plus b. We're told the slope is 5. So y equals 5 times x plus and we're told the y-intercept is 3. That's nice. And that's it. So the equation of a line will have a placeholder for x and a placeholder for y, right? Leave those as variables because then you can plug in whatever value of x you want and solve for what the y is at that point. Okay. Find the equation of the line that passes through the point 2, 7 and has a slope of 3, kind of next level, right? And so, but we start in the same spot. Okay, so let's start with y equals mx plus b. It's a good place to start. We're given the slope, so let's plug that in. Y equals 3x. But then I don't have the y-intercept, so I'm just going to leave it as b, and that's the next thing that I'm going to chip away at. How are you going to problem solve this? Has to pass through 2, 7. So x has to be 2 and y has to be 7. there it is. If x is 2, I know that y must be 7, right? It has to pass through this point, okay? And so what if I just plug in x equals 2 and y equals 7, and then I'm able to solve for b, right? And so here I'll make a little side note that we can substitute x equals 2 and y equals 7 to solve for b. They're just temporary, and I'll bump this down. Right? Because really what we want is we want to solve for b. So y equals, whoops, y was 7. 7 equals 3 times, try to be color coordinated here. 3 times 2 plus b. 3 times 2 is going to be 6. So I get 7 is 6 plus b, which means b must be 7 minus 6. So b must be 1. Start making some leaps here. Therefore, generically, y equals 3x plus 1. Leaving that x and y open to receive any value of x, and you can solve for y or vice versa. What's one way that you can check your work? You guys used Desmos before? Desmos. There's a calculator version or the graphing version. They're both free. And I use them quite a lot just to check my work and things like that. So I'll do it here. We had 3x plus 1 was the line that we found. Now I just want to confirm when x is 2, I think it was 2. Let's see here. If I force x equal to 2, it'll draw a line at x equals 2, but it'll also show me the intersection. And that line, that red line, which is the one we're working with and we developed, it does pass through 2, 7, it looks like. You could have avoided putting the x equals 2, but my iPad is usually a little bit finicky. It doesn't want to listen to me like this. But you could take it all the way to 2, 7. That shows you the values. Okay. Just kind of nice to be able to check your work. And so if you haven't used Desmos in a while, you can dust it off. If you've never used it, you can download it, play around with it. Like I said, it's free and just nice to be able to check your work. Okay. Ready for the next level? Okay. What's the next level? Wait. Guess I can't. I'll clean this up because I want to make it bigger. Find an equation of the line that passes through these 2 points, -1, 2 and 1, 8. Start in the same place. Okay. So you always start and you set up your framework, y equals mx plus b. Okay. And then your next step will always just be to find the slope. Sometimes I've given it to you, right? So far, I've given you the slope. If I don't give you the slope, then you would need 2 points, right? That this line is supposed to pass through, and then you can calculate the slope. Okay. And so here, we need to calculate the slope. Generically, m is y2 minus y1 over x2 minus x1. Oops. As always, it doesn't matter which point you force to be 0.1 and 0.2, right? As long as you're consistent, you don't want to be mixing them up. But I usually just let the first one be 0.1 and the second one be 0.2. It doesn't matter. M is, so y2 is going to be 8 minus y1, which is 2. X2 is 1 minus -1. Be careful with that minus -1, right? Because that becomes +1. 8 minus 2 is 6 over 1 plus 1 is 2. And I gotta, oops, I'll just add a page. Add a page. Uh, 6 divided by 2. I get a slope of 3. Okay. I've got a page break here, so I'm going to try to keep it on this page. Otherwise, it's going to span just the whole page. It's interesting. It's not that interesting. Whole page is worth. So now, right, you've calculated the slope, which is now you're back to this point, right? Has a slope of 3. Haha, surprise. I am surprised by that, actually, that they're the same, but that's okay. And instead of 1 point, you have 2 points. That's luxurious. Doesn't matter as long as you pick one from here on out, right? The methodology is the same, right? What you're going to do stays the same as what you did earlier. So from y equals mx plus b, we just found that y is 3x plus b. That's where we started here. So now substitute one of those xy coordinates in and solve for b. What color? How about green? Can you tell that's green? Yes. So now substitute one of the points for xy and solve for b. Would I do it over here on the slide? I don't like dealing with negatives. So usually I just avoid the negatives if I can, and I'm going to use 1/8. It doesn't matter. You're going to find the same value for b regardless of which point you used. Okay? And so if you don't like negatives, then join the club. So I get y equals 3x plus b at 1/8, for example. So then y is 8 if x is 1. 3 times 1 is 3, and 8 minus 3 is 5. So b must be 5. So then y is 3x plus 5. Make this more of an arrow. Nice. So first, find the slope. Second, find the y-intercept. Questions? Find an equation of a line that has x-intercept 3 and y-intercept 4. So we already have the y-intercept. That's nice. We're just missing the slope, right? But we also need some points. This is kind of a sneaky way of saying when y is 0, x is 3, right? And so this is going to translate into 3, 0, right? That's sneaky. How about the y-intercept? When x is 0, y is 4. So we are given points, just not explicitly. And so we have 2 points. So we're still given 2 points implicitly. I'll probably have something like that on a test, right? Where, okay, because we've talked about what is the x-intercept and what is the y-intercept. And so it kind of incorporates all those skills into one. And so that's why I like it. Right? Now we've seen it, not too bad. What if we just apply the same kind of method that we have been doing? We start with our y equals mx plus b framework, and then we can find the slope, and then we can find the y-intercept. Right? That's always going to work. So our slope find the slope. I'm gonna bump this down. M is y2 minus y1 over x2 minus x1. Let's say 0.1, 0.2, the order that they appear. So then y2 is going to be 4 minus y1, which is 0, and x2 is 0 minus 3. 4 minus 0 is 4. But then don't forget that negative. So I get 4 over negative 3. Usually what we do is, it's mostly so that you're not kind of missing it. We either float this negative out front or onto the 4. Depends on how I'm feeling, right? Or whatever looks best. For me, I usually put it on the 4 instead. So this negative is allowed to float around as long as you only have 1, right? And so I'm going to rewrite this as m is negative 4 over 3, because if I write it like this, it's so easy that these kind of run into each other and you might miss it, right? So that's my only kind of caution. I don't write it like that for that reason. I write it on the 4, and then you'll see it right away. negative slope. A negative slope looks like what? Looks like this, right, from last day. Okay. Which if we imagine, okay, I've got an x-intercept of out to 3 when y is 0 and a y-intercept at 4 when x is 0, then if I connect those dots, I am expecting a negative 1. So a negative slope makes sense. Right? I'll keep this, but I'll bump it kind of up top here maybe. Right? It's what we're expecting. And so then you get a negative slope. Right? If you have a negative relationship, get a negative slope. Okay. Find the slope. Then y equals negative 4 over 3x plus b. Solve for b. If you had a choice here, right, just find 2 points on this line. This is where picking convenient values of x is going to be coming into play more. What's a convenient value of x? Something that is divisible by 3, right? 3 would be nice, right? Then you're able to eliminate that fraction, right? And so I'd use things like 3 or 6 or 9 or something like that as convenient values of x. We're specifically trying to solve for b, but I will use kind of the same method, right? We're told the y-intercept is 4, but let's pretend we don't have that for just a minute, right? You could just say b is 4. That's fine. That's allowed. Okay. But let's try it with the x-intercept instead. B equals 4 from the question. I'll highlight that we knew that, but I want you to see that it'll always work. Okay. So what if we use solve for b using 3, 0 instead? Right? If you plug in x equals 0 and solve for b, you get 4. Fair enough. But let's do a little bit more work here. Y is 0. Negative 4 over 3 times 3 plus b. We're trying to solve for b. This is a fraction multiplied by a fraction. Right? 3 I can rewrite as 3 over 1 if I want to. Right? I'm not going to, but I could. And if I'm multiplying, then I'm allowed to cancel these 3's, right? This 3 can be written as 3 over 3, negative 4 times 3 over 3. 3 over 3 is 1, right? And so then that's how I get to 0 is negative 4 times 3 over 3, but I'll highlight here that this is equal to 1. Negative 4 times 1 is negative 4. Right? And so that's how they cancel. They don't just go away. They morph into 1. Multiplying by 1 just goes away. Plus b. So then I have negative 4 times 1 plus b is equal to 0. And if I add 4 to both sides, I get that b must be 4. Therefore, y equals negative 4 over 3x plus 4. Huh. Hopefully you've seen the 3 triangle dots, therefore, it's shorthand for therefore. suspect I've been using it already quite a bit. Just caught myself. Sure. Nice. So being able to construct a line is kind of the name of the game today. What's another form of a line that we could use? Now, in this section, we introduce all three forms of a line. They'll do the same thing. I'm going to rely heavily on the point or the slope intercept form, which is y equals mx plus b. But it's good to have seen these other forms and kind of worked through them. Yeah. So the point slope form of a line is useful when we know 2 points on the line. We've seen that already, and we want to find the equation of the line. Okay. If we have a slope of m, which we've already seen, right? We said, okay, if I have a slope and it has to go through these 2 points, right? We know how to solve that. But what we can do is we can rearrange. It's on there, but I want to show you. I'll take it one step further. If we have y equals mx plus b, what if I replace m with the equation for the slope? Then I might have y equals y2 minus y1 over, x2 minus x1 times x plus b. What if I let the second point just be xy, some generic xy? Then I just saw that I have jumped the gun. Sorry. Haven't I? I have. I took it too far. Rein it in. Sorry, guys. Like, and then you can just rearrange it and just do this and just be a lot of justs in a row. No, we're not going to do that. How about this instead? All right. I'm still not terribly thrilled, but we know if I let m be y2 minus y1 over x2 minus x1, yeah, if I only have the first point, right, then I can let, so if we only know, x1, y1, we can replace x2, y2 with just xy as kind of generic placeholders. We can replace x2, y2 with xy just generically. That's a y. Sorry. So then the slope becomes y minus y1 over x minus x1. What I can do is I can multiply this x minus x1 over onto the m. Now, I'm not just going to do that. I want to show you just why we can do that. Yeah. I'm going to multiply by a convenient value of 1, right? We know if I take 3 times 1, it becomes 3. Anything multiplied by 1 is just itself, right? And so I'm going to rely on that property. Okay. So what I'm going to do is if I want to move this x minus x1 over to the left-hand side, okay, what's going to happen here is, I keep trapping myself too much. I can multiply. Let's do it. X minus x1, but as long as I do it to the other side as well. This is technically x1, x minus x1 over 1. And on that side too. I said x minus x1 over x minus x1, but I take that back. So why did I do that? As long as I do it to both sides of the equal sign, equality remains, right? And so now the reason I did it is because now if I treat this as one thing, x minus x1, then I can cancel them just like we did earlier. Okay? So now I have x minus x1 times m. It's general convention that we write kind of the single thing in front of a bracket of stuff. I know technical terms, right? And so mostly because otherwise you might miss the multiplier of m. Okay? So I'm going to rewrite it as m times x minus x1. It doesn't matter. A times b is the same as b times a. That's a fact. Right? But this becomes y minus y1. So now you can rewrite the order, right? Usually we have y on the left-hand side and everything else on the right-hand side. And so let's rewrite it. Y minus y1 is m times x minus x1, which is this here. Okay. The only difference is if you have a point and you have the slope, right, x1, y1, and m, then if you prefer, you can just plug in that x1, y1, and the m, and then you have the equation of the line. Okay. How would you need to, nope, stop, full stop. I was going to rework it back to the slope intercept form. You can do that. Okay, fine. Let's do it. What's the slope intercept form? Y equals mx plus b. Okay. So now, a little bit more work. It's okay. So moving from y minus y1 is equal to m times x minus x1 to y equals mx plus b. Seems reasonable. We start here at y minus y1 is equal to m times x minus x1. I can add y1 to both sides so that I can have y on the left. So y is m times x minus x1 plus y1. Not quite in the y equals mx plus b form yet. right? What do I need to do? I need to distribute that m inside the brackets. And so we have y equals m times x minus m times x1, and then plus y1. That looks kind of familiar-ish, right? You can lump this into a b. Right, mx plus b. If b is, let's say, y1 minus the slope times x1, just so I don't have that minus mx and then plus y1. Right. Then I have y equals mx plus b, where b is now a placeholder. Let's try it. Let's try it maybe with this equation here. Copy. And we had the point, or maybe I shouldn't use that one. Let's do the second to last one that we did. Wait. 3x plus 5 and going through the point 1, 8. Okay. So here, consider y equals 3x plus 5 through 1, 8. Okay. In this case, we know that b is 5. Right? We know b is 5. And we know m is 3. But what if we use this format instead to solve for b, right? We plugged in the x and the y, and then we rearranged and we solved for b, which is the same motion that we're about to go through, right? Just kind of more standardized. So where can I move these to? B is y1, which is 8. Should do it properly. Just need more room, but not a ton more room. There. If b is y1 minus m times x1, then b, if I'm not changing anything on one side of the equal sign, you can just leave it empty, which it doesn't really matter if you're just writing b all the time, but eventually, right, we'll have kind of a lot going on one side, and if nothing's happening, you don't really write anything until you're starting to use it again. And then stack your equal signs. So y1 in this case is 8. Minus m we had was 3 times 1. So 8 minus 3. So we knew that b was 5, but this is just another way that we could have gotten there. Kind of a roundabout way. So it's not something I'm expecting you to do, but moving between the different forms of a line makes us flexy, algebraically flexy. So that's good. It's good practice. Okay. Questions? No. And I'll bump these down a bit. Find the point slope form of the equation of a line that has a slope of 1.5 and passes through the point 12, 4. Point slope is y minus y1 is m times x minus x1, right, from earlier. Yeah. So you have a point and you have a slope, and you can plug those in and resist the urge of solving for a y and rearranging into y equals mx plus b. You don't have to, because it's asking for the point slope form. So y minus 4 is 1.5 times x minus 12. I'd say technically you're done there. That is the point slope form. Done, but let's simplify for fun. When I simplify, it usually turns into slope intercept form, y equals mx plus b for me. It's my go-to. Y is 1.5 times x minus 12 plus 4. Expanding that 1.5, 1.5 times x, minus 12 times 1.5. I don't know. How can anyone know? 18. And then plus 4. Negative 18 plus 4, just to be safe. Y is 1.5x minus 14. With all these different forms of a line, right? All you need to remember is that, okay, if you see an equation with just one x and one y, you can rearrange it to an equation of a line, right? As long as there's no powers on the x's or the y's, and you're able to kind of collect like terms and simplify to just get an x and a y, then you have a line, then you have a straight line. Okay, let's see here. As if there weren't enough forms of a line. The standard form of a line has the form ax plus by is equal to c. Okay. So if we know the equation of a line in point slope form, like we just talked about, or if we know the equation of a line in slope intercept form, then we can move all our x's and y's over to one side of the equation and keep our constant on the other side. Okay. And so the x's and y's to have all the terms for the xy variables on one side of the equation. I guess I should highlight that too. And the constant on the other side of the equation. I don't really remember saying it, but I'll say it now. If I have something multiplying x and y, those are called coefficients. Okay. And so this is the coefficient of x, right? A is the coefficient of x and b is the coefficient of y, and c is the constant, because it doesn't have anything being multiplied by it, so it's just a constant. as an exercise, you could take y equals mx plus b and rearrange it into the standard form, right? What would you have to do from y equals mx plus b? You'd have to subtract mx from both sides, and then you get y minus mx equals b. Right? Or the point slope form is a little bit more involved, right? You'd have to expand your mx minus x1, right? Or expand your m into your brackets and then rearrange, right? But that's okay. That's okay. Using the point slope formula, point slope, I have to remember which one's which. The clue's in the name, right? It has a point and the slope in the name. So the point slope is y minus y1 equals m times x minus x1. So we're going to start there, and then we're going to find the standard form of an equation of a line that passes through the point 2, 3, and has a slope of -3/5. So first we need to find the equation of this line using the point slope formula. That's some work, right? That we already know how to do. And then, like I said, we're going to rearrange it. It's almost like I knew it was coming into the standard form. Okay. But let's start with y minus y1 is m times, I'll show you that, x minus x1. Okay. We have a point 2, 3, and we have a slope -3/5. So I have y minus 3 is -3/5 times x minus 2. That's what's nice about the point slope formula. You have the slope and the point, you just plug them in and then you're done, sort of. There's usually more to it than finding the equation of a line. Okay, but now I want to rewrite this in standard form, right? Standard form is when I have ax plus by is equal to c. So everything ax and y goes on one side and c goes on the other side. So anything that's just a constant goes on the other side. First thing I need to do is distribute this -3/5 into the x minus 2. So let's see here. Y minus 3 is -3/5 times x. And I'm going to do -2 times -3/5. Usually I multiply kind of on the left, but then if I have subtraction, I want to make sure that I keep that -2 and I don't want to lose it in the shuffle. And so that's why I'm writing the -2 and then times -3/5. A negative times a negative makes a positive, right? Or addition. So if I simplify this, let me just put it down some more. I get y minus 3. And if you wanted to start off by moving that -3 over by adding 3 to both sides, that's totally fine. Depends on what you like. I kind of wanted to jump in and tackle that fraction head on. -2 times -3 makes +6, right? And so now I'm left with +6/5. Technically multiplying fractions. -2 is technically 2/1. And multiplying, you can just multiply across. Do you guys remember your fraction work? We'll see if we get any coming our way, and I'll remind you as they come. But multiplying fractions, you're allowed to just multiply across. Not the same with addition and subtraction, right? And division. Ugh. Okay. So now, whoa, what did I do? Okay. There. That's all I wanted was my pointer. I want to move all my X's and Y's over to one side and all just the numbers to the other side, right? And so here, really didn't give myself enough. I was just kind of winging it, so who knows? -3/5x. I'm going to move it over to the left-hand side because then I get addition instead. And in the same maneuver, I'm going to add 3 to the other side. So kind of show you where I'm going here. Doing a little switcheroo, which is going to look like this. Y plus 3/5 times x is 6/5 plus 3. From here, I guess we had to have the coefficient, the x component first, and then the y if we want to use a and b and c, just like we have here. And so we'll rearrange this side. That's easy. 3/5x plus y. But simplifying this side is not as easy, right? 6/5 plus 3. If you've got a kind calculator like mine, I can do 6/5 and then plus 3. And it tells me it's 21/5. I know, cheating, right? But if you don't have a nice calculator like that, I should say a kind calculator, an engineering calculator. I think the easiest way to combine these, right, is to get them over a common denominator. And so here, we need a common denominator. Denominator is on the bottom, right? And so let's take it all the way back. A fraction has a numerator over a denominator. Like a lot of things, you only need to remember one. And so, and I had a heck of a time, and so then I started saying, well, the numerator is numero uno, so it's on top, and then the other one's on the bottom. That's all you need, right? Just need to remember one, and then the other one will follow, right? And so we've got a numerator and a denominator, and so we need a common denominator. The easiest way, not the fanciest by any means, is to just force a common denominator of 5. And so how can you do that? What if I multiply by 5/5? This is where that fancy 1 comes in. This is getting, I don't know, way ahead of myself, but also tripping myself up. Why am I allowed to do that? Multiply 3 by 5/5. 5/5 is just 1. I'm allowed to multiply things by 1. It doesn't change them, right? And so that's the trick. So then I have 3 technically over 1. 3 is a fraction. It's just happens to be simplified, right? 3/1 times 5/5. So 3 times 5 is 15 divided by 5. No surprise that that simplifies to 3, right? That was our goal, right? We don't want to alter anything because we have an equal sign to tend to here. But that means we have 6 over 5. Uh-oh. Plus 15 over 5. Too much math. Now I have a common denominator, and now I'm allowed to add those numerators and put them over the common denominator. Oh, wow. Bump. So now I have 3 over 5x plus y is 6 plus 15 over 5. All right. I'll just highlight that that 5 stays the same. So you don't add the common denominator, just stays the same. 6 plus 15 is 21. Hey, that's exactly what my calculator told me. 21 over 5, I think. Just a little quicker. So now I get 21 over 5, and I have 3 over 5x plus y. Mapping this to the general form, ax plus by is equal to c, then a, the coefficient of x, is 3 over 5. What's b? B must be 1. Right? And so 1 times y, usually we don't write that 1. And then c is 21 over 5 in the exact form. Wait. Come on. What if you're given 2 points and you want to find the standard form? The standard form is this new one, ax plus by is equal to c. How about this? I'll let you try it on your own. I'll pause it. I'll pause the video, and then I'll also just write it out, but I want you to try it. I'll pause this here though. Let's see here. Resume recording. Yeah. I changed my mind. Bump these down. Okay, but I do want you to try it. Try it on your own. Lots of different problem solving things that you need to do here, right? Which is healthy and fun at 5:15 at night. Math is for the morning, not for nighttime. Hopefully I didn't muck it up. Usually I'm counting on you guys to call it out. Did this wrong. Start here. Did anyone else get this? Got one thumbs up? That's cool. Even if you're not quite finished. Same technique as before, right? Any equation of a line, start by, if you don't have the slope, you have to find the slope, right? That's your first thing that you need to do. Next thing, if you don't have the y-intercept, you need to find the y-intercept, right? And so I always find that that's easier. It's always easier. I've already confessed, it's easier for me to work with the y equals mx plus b version of a line. And so that's what I'm always working towards. The point slope form is useful, but not, more useful than y equals mx plus b, in my opinion, at least for our purposes. So then I find the y-intercept, the b, and then I can write the equation of a line. I can put those two things together, and now I have y equals 2 over 3x minus 8 over 3. Then I need to rearrange to put it into the standard form, ax plus by equals c, and I do that. I move some things around. X's and y's have to be on one side, and ideally x first and then y, but I keep bunging that up. So then I have to do another line. But then a would be negative 2 over 3, b would be 1 again, and c is negative 8 over 3 in that case. Nice. This point, standard form is ax plus by is equal to c. Oops. Not too bad, right? We just did it. We just did a way more complicated version of this question, but let's try it. And so I have y is negative 2 over 3x plus 3. I want to get the x's and y's to one side and then the constant on the other side. And I'm going to try to do it with the x first. Okay. So I have to add 2 over 3x to both sides. 2 over 3x plus y is equal to 3. I did it. In this case, a would be 2 over 3, b is 1, and c is 3. Way easier to move from, I was going to say whatever point form or whatever slope form this is, but slope intercept form to standard form. Like I said, it's not something I expect you to know. If I'm asking for you to rewrite it in standard form, I would put in brackets ax plus by is equal to c, right? Just to kind of remind you. On an assignment question, I might forget to, but you're working together and you've got your textbooks and you've got all your notes and everything, so you can look it up, right? But in a test situation, no, that's not something I expect of you. Write the equation 3x minus 4y is equal to 10 in the slope-intercept form. Slope-intercept, my favorite, y equals mx plus b. All you need to do here is rearrange and solve for y, right? Push everything else to the other side. And so we have 3x minus 4y is equal to 10. if I want to solve for y, what's my first thing? I need to start chipping away at this y here. But before I can get to the -4 times y, I need to move 3x over to the other side. And so I need to take -4y is 10 minus 3x. Then, solving for y, I would need to divide both sides by -4, right? And that's going to cancel that -4 coefficient. And so then I get y is 10 minus 3x over -4. It's important that that -4 is dividing the entire thing on the right-hand side, right? And so here, so I'm happy if you leave it like that, or if you want to split it up into two fractions, then you can rewrite it as 10 divided by -4, but I'm going to float that negative out front onto the 10 instead, right? Just so it doesn't get lost. Minus 3x divided by -4. But these, I wrote it down in the bottom because it's about to go away, right? Subtracting a negative is addition. And so now I have y equals -10 over 4, which can simplify, but nah, plus 3x over 4. If you're splitting those fractions, right? Which means that if we had to find the slope, right, now it's easier to see that the slope here is positive 3 over 4. Right? Just as kind of a fun fact, by solving for y, it can easily be shown. I don't know if you've read a lot of kind of math research papers, but whenever they say it can easily be shown, it's not. It's like very elaborate. Oh yeah, it's so easy. But it can easily be shown that the slope of the line ax plus by equals c, right, which is where we started here, 3x minus 4y is equal to 10, right? If we look and say, okay, then we rearranged everything, we solved for y, we found that the slope is positive 3 over 4, right? Which generically is going to be negative a over b. The reader should verify this. Well, let's do it. In fact, let me make some room here. Paste. Not make room, but separate. Oops. Crop top, there. What are we going to do? That's the same as what we just solved, but instead of 3 and -4 and 10, we just have a, b, and c. That's okay. Ax plus by is equal to c. Solving for y, solve for y, I get by is equal to c minus a times x. Divide both sides by b, I get c minus a times x divided by b. Same method, right? If I want to rewrite these as kind of separate things, then I have y is c over b minus a over b times x. whatever is multiplying the x is the slope, negative a over b, right? In the form y equals mx plus b. Right. So you could rearrange these, but I'm not going to bother. Right, so that's kind of fun. So if you're able to identify A and B, right, then as long as you remember to take the negative A over B, that's your slope. So find the slope of the following lines by inspection. We're going to use M is negative A over B. For this first one, for A, I have a slope of negative 3 divided by negative 5. It's virtual paper. I don't know why I try to save space, but there. I do. 3 over 5. Negative over a negative, they're going to cancel out. And so we get M is 3 over 5. How can we check it? You can use Desmos. You can use Desmos and you can draw 3x minus 5y is equal to 10. 3x, now I don't remember what it was. Can I do that fancy thing? Yeah. 3x minus 5y is equal to 10. Usually you can just kind of plug in whatever you want to look at in Desmos, which is really nice. We've got a tricky slope. What could I do? I could make up a line 3 over 5 times x with a y-intercept of 0. Doesn't matter, right? I can move this line, but as long as it has the same slope, right, then that's a good place to start. So we found the right slope because those two lines look parallel, right? They have the same slope if they're parallel. Okay, nice. Let's inspect the next one. I have an A and I have a B, and we want to find the slope. And so I have negative 2 over 7. The only thing you need to check if you're using this method, which is, just another method to have up your sleeve, is you do have to have it in the form of ax plus by is equal to c. Okay? But then you should be good to go. And c, we have negative 4 divided by negative 3. Oops. So m is 4 over 3. I'll use Desmos to check these. I'll delete these old ones because otherwise there's going to be a lot of lines on here. 2x plus 7y is equal to 20 this time. And let's just draw a line that has a slope of negative 2 over 7 times x. Those look parallel. I'm not showing a ton of the screen, but those look parallel to me. So that's good, right? If they have the same slope, they're parallel. And 4x minus 3y is equal to 8. And how about a slope of 4 over 3 times x? Looks good. Nice. Okay. All right. Wait. 3 ways of saying the same thing. Actually, many ways of finding the same thing, the equation of a line. How about this? If you want to stick around and start these problems on your own, we can do it here in class, but I'll kind of let you decide. It's late. But I do want you to try these 1.4 problems. See how it's just problems, no concepts? No new concepts. Now we're taking what we know about lines and we're applying them to word problems, everyone's favorite thing, right? And so I want you to try those, the rest of the questions on your own, and then we'll go through them together in class on Thursday. Okay? But you're welcome to bring it home and work on it at home. That's fine. If you have any questions, let me know. Otherwise, I'll see you on Thursday. Stop this.